Module 1.2, we will be discussing about transistors in this particular module. What is a transistor? You would have studied this in your +2 physics for sure. Transistor, for our understanding, is nothing but a switch. So, what is a switch? So a switch basically connects one part of what you call as source to another end, which you call as drain. A switch basically connects this source to the drain, right. So, when the switch is on, the source is connected to the drain. When the switch is off, the source is disconnected from the drain, right. So, this is the basic on off switch. So, the transistor essentially behaves as an on off switch. There are two types of transistors. One is called a P transistor and another is called an N transistor. As we had mentioned, since the transistor is a switch, the P transistor is symbolically represented like this, where there is a source, there is a drain and there is a gate. This is called a gate, which will connect the source to drain when the transistor is on and which will disconnect the source to drain when the transistor is off. So, this is the P transistor. Please note that there is a small bulb circle here. So, this is the P transistor. There is another type of transistor which is called the N transistor. It also behaves in similar fashion. So, this also has a source, this also has a drain and this also has a gate. The distinguishing feature between the P transistor and the N transistor symbolically is there is no circle here in N transistor, but there is a circle here. So, what is the difference in the functioning of the N transistor and the P transistor? The difference in the functioning of the N transistor and the P transistor is when the N transistor, when the gate is 0, N transistor is off. That means the source is not connected to the drain. When the gate is 1, then the N transistor is on. That means the source is connected to the drain. On the other hand, P transistor works exactly opposite. When the gate is 0, the P transistor is on, while the gate is 1, the P transistor is off. What do you mean by 0 and 1? 0 and 1 are basically voltages. The 0 corresponds to what we call as the ground voltage, the 1 corresponds to what we call as the supply voltage. So, the transistor has a supply voltage and there is a ground voltage. So, when for our understanding, if I apply the ground voltage to the N transistor, it gets off. If I apply the supply voltage, then it gets on. The exact opposite happens in the case of the P transistor. For you to quickly remember, N transistor works normally. Normally 0 means off, 1 means on, right. So, the N transistor works in that normal fashion. The P transistor works exactly opposite to it. So, this is how we can make a distinction in the functioning of the P transistor and N transistor. Now, the entire computer, your mobile phone, which has close to 1 billion transistors now, has such transistors, and the entire system is built out of these transistors. Very quickly we will see what is it that we can do using this N and P transistors, right. So, I will now give you a simple circuit in which you give a 0 you get a 1, and when you give a 1 you get a 0. So, this is called a NOT gate or an inverter circuit. So, how is a NOT gate formed? Let us see how it is going to be. I put a P transistor, I put another N transistor, and I connect them together. This is the drain, this is also the drain, this is the source, this is the source. Now, to this part I basically give the supply voltage what we call as VCC, and to this I put the ground, which is the ground. Now, this is the input I am giving to the circuit, and this is the output I am going to collect out of the circuit. Now, suppose I give a 0 as an input. When 0 is applied to the P transistor, what will happen? It is switched on, that means the source is connected to the drain. When I give a 0 to the N transistor, what happens? It switched off, and that means the source is not connected to the drain. So, this is basically open. So, since this source is connected to this drain, this means this is now a short for all practical purpose. We can view it as a short, and this is open because this is disconnected. So, this point and this point are the same. So, when I measure the voltage here, what will I get? This is VCC and this is VCC, and I measure, I get VCC, that is 1. So, when I apply a 0 to this circuit, I basically get a 1. Now, let us go and apply a 1 to this circuit. When I apply a 1, the N transistor is switched on, that means this source is connected to the drain, while the P transistor is switched off. So, this is open. So, this point, as you see, is equal to this point because this is closed and this is open. So, when I measure the voltage across this, what we get is ground because these two are same. So, I get ground voltage which is 0. So, when I apply a 1, I get a 0. So, now this is the it is the NOT gate, wherein this is the input and this is the output. When I apply 0, I get a 1, when I get 1, I apply a 0. This is represented by this symbol in digital electronics. So, this is how a NOT gate is built out of a simple inverter. Now, let us build. So, this is basically a unary gate because it has one input. This has only one input. Now, let us build something which is a binary gate. I put one P transistor here, another P transistor here, and I put 2 N transistors here. So, let me just this is ground and this is VCC and this is output. These are the inputs, this is A and B. The same A and B are given here also. Okay. Now, let us see. So, what are the different inputs I can give for A and B? So, I can give a 0 or a 1 for each. So, these are all the probable these are all the possible combinations. I can give a 0 0, 0 1, 1 0 and 1 1. So, these are all the probable possible combinations for A and B. So, let us see 0 0, 0 0 0 0. The same A is given here, same B is given here, right. When 0 is given, this is on, this is also on. That means your source is connected to the drain. While this is off and this is off, these being N transistors, given 0 they are off, that means these are disconnected. So, when I look at this point, since both of them are connected, this point and this point are the same, right, because these are essentially for all practical purpose it is behaving like a short, because these are open, these are on, that means source and drain are connected. So, when I apply the when I measure the voltage here, what I see is 1. Now, let us go for to the next step and say I am applying 0 1. Zero 1, 0 1. What could happen? This is on, this is off, this is off and this is on. So, now what happens? Since this is off, that means source is connected to this source is not connected to drain, this whole circuit here as you see, since this N transistor is off, this whole circuit as you see here is off, is disconnected. So, this is open, while since this is on, though this is off, there is a short from VCC to this output. So, when I measure the output here, output at this point here, since this N transistor as you mark is off, so this entire part here as you see is out, it is disconnected to the ground. So, the VCC is connected to the output. So, when I measure the signal at this part across this output, you basically get a 1. The same thing happens when I apply 1 0. One for A and 0 for B. Note that the N transistor to which B is connected is off now, though the A transistor is on, but since they are in series, this entire part of this N part is disconnected, while the P transistor to which A is connected is off because you have given 1 here, but the B transistor is on because you have given 0. So, the VCC, there is a path between VCC to output. So, when I measure the output here, so you get VCC, that is 1. Now, let us take the last part which is 1 1. When we put 1 1, both these A and B, that both the P transistors to which A and B are connected, they are now disconnected, because you are given 1 to each and they are P transistors. So, P transistor, if I give 1, it is off, and both the N transistors are on because we are given 1, both the N transistors are on. So, that means this output spot and this ground is connected to the output, because this is, for all practical reason, this entire part that I am shading here is going to be a short, while there is no connection between VCC to output. So, what happens is, when I measure this, it gives me a 0. So, this is a function which takes 2 inputs and gives me an output. This gate is called a NAND gate. And this is given by this symbol, given AB, and this is the output. The behavior of this NAND gate is basically described by this table, which says that if you give these 2 inputs, this is the output, and for every combination of this input it gives the output. So, what we see here, this is called the truth table of the NAND gate. Similarly, if you go to the previous one, this is the truth table for the NOT gate. Right. So, what we have seen in this course, in this particular module 1.2, is about transistors and how we can use transistors to build basic gates. Now, the entire system is now built using these gates. So, specifically in this course, we are going to build an entire computer using these NAND gates, and we will see how it is going to happen. Thank you.